Okay, so here we have a brief tutorial on how to do the prime factorization using the ladder or cake method. So we call it the ladder or cake method because of the way it's going to look, and to do that we're basically going to use an upside down division bracket. So the same way that when we would use the standard algorithm for division or long division, right, we would say 36, 6 goes into 36, this is how we would draw it, but we're not going to do that. Here, if we're looking for the prime factorization of a number, again, the prime factorization of a number is the number written as a product of all its prime factors. So we could say 12, right? 12 equals 2 times 2 times 3. That's the prime factorization of 12. The way we would discover that is by taking this 12 and drawing a bracket underneath it, right? So see, it's like the inverted version of the division bracket. The first question we would ask ourselves is what prime numbers go into that? And I like to use the algorithm of stepping our way up using the lowest possible prime number and then moving to the next. So a good list of things to know is your list of prime numbers, and in this slideshow I've included that list that I believe you should know up to 19. So 2, 3, 5, 7, 11, 13, and then down here we're going to lose, I'm just going to slide up a bit, 17 and 19. So you're going to start at 2 every time and ask yourself the question, does 2 go into 12? And in this case, yes, it does. 2 goes into 12, and just like a division problem, you would say it goes in 6 times. I then draw a new bracket, and you can see where that ladder or cake method is coming in. And then I'm going to ask myself again, does 2, starting back at the top of my list, go into 6? In this case, it does. And it's going to render an answer that is also a prime number, and that's when your algorithm tells you to stop. So in this case, your prime factorization, 12, equals 2 times 2 times 3. And that's pretty much it. This can be done for larger numbers as well, right? And we can take a look. Let's choose one here. Let's take a look at a number 39. Okay, so we still have the same list, 2, 3, I shouldn't have erased that, 2, 3, 5, 7, 11, 13, 17, 19. Now, we ask ourselves, does 2 go into this number? 2 does not go into 39. 39 is not divisible by 2. So we don't put a 2 here, but 3 goes into 39. 39 is divisible by 3. We know that because 3 plus 9 is 12, and 12 is divisible by 3. That's our divisibility rule. So we put 3 here, and we ask ourselves, does that go in? 13 times, yes it does, so 39 equals 3 times 13. So you can see that sometimes the number is larger. And I'm going to give you one more example. We will start with 100, okay, just so that way we have some answers here, okay. So 2 does in fact go into 100. It goes into it 50 times, and if you didn't know that, you can pull over to the side here, do a little bit of division, say how many times exactly does 2 go into 100, and you would get obviously 50. So long division is not the purpose of this video, so we're not going to do it right now. I continue to draw my bracket. 2 goes into 50 because I'm asking myself the same question. Yes, it does. Now it goes to 25. Same bracket. Does 2 go in? No, it does not. Does 3 go into 25? 2 plus 5 is 7. This is not divisible by 3. Does 5 go into 25? Yes it does. 5 times, and then 5 is my answer here. So since again I've rendered a prime number, I get my answer 2 times 2 times 5 equals 100. That's the prime factorization using the ladder cake method. Thanks.